So we're going to talk about areas of circles, sectors, and segments. All right. So hopefully we all will remember how to find the area of a circle. What's our formula for the area of a circle?
Pi r squared.
Pi r squared, units squared. Square inches, square meters, square feet, something. So that's our basic formula. We've been working with that at least since middle school, if not before. So hopefully remember that one. So let's look at a quick example, finding the area of a circle. So here's my circle. Circles are easy, circles are friendly. All right, so that is 48 meters, and we want to find the area. So how am I going to calculate this? Area equals, what am I going to put there? Pi times 24 squared. And why is it 24? The radius is half the diameter. All right, so if I calculate this out, I get 576. 24 squared is 576 pi. And that would be my exact answer, or my answer in terms of pi. 576 pi square meters. And if we wanted an approximation rounded to the 10th, that's about 1809.6 square meters. And I just get that by multiplying 576 by pi. So, circle is nice, friendly, pretty easy. But we also want to be able to find areas of parts of circles. So we're going to talk about area of a sector. Sector is a piece of a circle. So let's draw a picture of a sector. Here is our circle. I'm going to say this is R, S, and P. And the sector is this shaded part. So that's a sector. We name it, we call it sector RPS, just like we name an angle. The vertex is in the center. Sector RPS. The sides of the sector are radii. Radii, just a plural of radius. So the sides of our sector have to be radii. And to find an area, the area is a fraction of the area of the total area of the circle. And motivated by what we did on our opener when we found the arc length, how do you think we're going to find that fraction of the circle that this sector takes up? Any ideas? So on our opener, how did we figure out the fraction of the circle that the arc took up? Divide what by 360? The angle, right? We divided the angle by 360. Same thing happens here. The area equals the measure of arc RS, the angle, this angle, divided by 360. times the area of the entire circle. This tells us the fraction. And that's the total area. So we'd say it has a radius r. This is the fraction it takes up. So I'm going to say the fraction of the total area. And this is the total area. So we multiply the fraction by the total area to get the area of that piece of the circle. And this angle, the arc measure divided by 360, the exact same fraction that we used when we found the arc length. That tells us what fraction of the circle this thing takes up. All right, so questions there so far? All right, so let's look at an example. So here is our circle. Here is my sector. And I'm going to say this is 84 degrees, and this is 9 millimeters. And this is R, T, and S. And we want to find the area of sector RST. So we're looking for the area of that little piece of pie there. All right, enough. So our area equals, so we need the fraction of the entire circle it takes up. How do we find that fraction? (84/360). That tells us the fraction of the circle that sector takes up times the area of the circle times pi times 9 squared. And we just multiply this out. So 84/360, I get 0.233 times 81 pi. 9 squared is 81. If I multiply this out, I get 18.9 pi square millimeters. This would be an answer in terms of pi. If I multiply 18.9 times pi, I get about 59.29 square millimeters. The what? 81. 9 squared is 81.
So what's the difference between like pi r squared and 2 pi r?
Pi r squared is the area. 2 pi r is the circumference. So 2 pi is pi plus pi. R squared is r times r. All right, questions? Questions there? Okay. There's one more piece of a circle that we want to find the area of. A segment. Let's draw a picture of a segment. So here's our sector. And then I divide off this triangle the area of, we're looking for the area of this piece. So that is a segment. To find the area of a segment. So we take the sector and we chop off a piece from the ends of the radii. To find the area of a segment, we're going to do it in steps. So we need a couple different pieces. So I'm going to draw 3 circles here. to show what we're going to do. And I'm going to try to draw all of these so they look more or less the same. And then, so we're going to do our equation in kind of like a picture. All right, so to find our area of our segment, first we're going to find the area of the sector. So we find the area of that piece. We're going to subtract the area of the triangle. And that equals the area of the segment. So we find the area of this whole piece, then we subtract the area of the triangle, that gives us the area of this segment. So there's our little, our picture equation. We have to find our area here in two pieces. All right, questions on how we go about it? Okay, let's do a couple of calculations. Start off with an easy one. So here's our circle. And you'll find a lot in math that you turn problems, if you can, turn them into problems that have to do with circles, because circles are nice and friendly. And then often you'll turn problems that have to do with circles into problems that have to do with triangles. So we want to find the area of this segment. So we know that the area of the segment, and we can think of it, I'm just going to write it out this way kind of in shorthand. The segment equals sector minus triangle. That's how we're going to go about this. So let's find the area of the sector. So we need the fraction of the circle that the sector takes up. Well, what fraction of the circle does 90 degrees take up? What is it? 25%, or as a fraction? 1/4. But we could also do 90 divided by 360. That would give us 1/4. 1/4 the area of the circle, pi times 7 squared. So that's 1/4 of 49 pi. And if I calculate that out, that's equal to 12.25 pi square inches, or approximately 38.48 square inches. So that's the area of the entire sector. Now let's find the area of the triangle. What formula are we going to use for the area of the triangle? Base times height divided by 2. What's the base of this triangle? 7. What's the height? This is a 90-degree angle. Isn't that the height? And how long is that? Isn't that also a radius? So that's 7. 7 times 7 divided by 2. So 49 divided by 2, which is 24.5 square inches. So the area of our sector is 38.48 minus 24.5, which equals 13.98 square inches. The sector minus a triangle. All right, questions on what we did there? All right, let's take a look at one where that takes a little more work. Where you have to be a little more clever to figure things out. All right, so we're trying to find the area of that segment. And I know this is 120 degree arc, and this is 6 centimeters. All right, so we know we're going to use the same process. The segment equals sector minus triangle. So let's start out with the sector. So we're talking about this whole sector that takes up 120 degrees of the circle. What fraction of the circle is that? 1/3. 120 degrees is 1/3 of 360. If you didn't remember, you could do 120 divided by 360. You get 1/3 or 0.333. So our area equals 1/3 the area of the circle, pi times 6 squared, which is 1/3 of 36 pi, which is 12 pi square centimeters. And if I plug that in my calculator, get an approximate answer. 12 pi is about 37.7. 37.7 square centimeters. All right, let's find the area of the triangle now. This one takes a little more work because we don't have a height and we don't know the base. Here's our base. Well, let's draw in a height. There's a height. From the vertex, 90 degrees to the opposite side. That little blue segment is my height. Well, if this entire angle is 120 degrees, what happens to that angle when I draw in the height? Bisects it. So this angle becomes a 60-degree angle. What does that make this angle? This is 90, so this has to be a 30-degree angle. There's a 30, 60, 90 triangle. So we can, once we have our 30, 60, 90 triangle, we're set. To go from the hypotenuse to the short side of a 30, 60, 90 triangle, what do we do? Divide by 2. So the height is 3 centimeters. To go from the short side to the long side, what do we do? Multiply by square root of 3. So this piece is 3 square root 3. So the height is 3 centimeters. And if this piece is 3 square root 3, how long is the whole base? Twice that long, so 6 square root of 3. Base equals 6 square root of 3 centimeters. So the area equals the base, 6 square root of 3, times the height, 3, divided by 2. 3 times 6 is 18. Square root 3 divided by 2, so we get 9 square root 3 square centimeters, which is about 15.6 square centimeters. So finally, the sector area equals the segment area is the area of the sector, 37.7, minus the area of the triangle, 15.6, and I get 22.1 square centimeters. And there's my answer. And this one we had to work with our 30, 60, 90 triangle that we got because that was a 120 degree arc. All right, questions there?
Will it always be a 60-90 triangle?
Not necessarily. So we might have to use the Pythagorean theorem. We might have to use trigonometry. We might have to use SOHCAHTOA to find missing parts of the triangles. But we have all of those tools that you can find missing pieces. But there has to be enough information so that you can use something like that if you don't have all the pieces. Yeah.
I think that's very
So this piece is 3 square root 3. We've divided this in half. So that piece is also 3 square root 3. So 3 square root 3 and 3 square root 3. All right, other questions? Okay. Homework. No. All right, there we go.